Okay, we're going to be looking at 8.4 rational functions. We're going to identify the vertical asymptotes, horizontal, domain, range, removable discontinuities. Please have your foldable out, which talks about the holes and everything I just mentioned. It gives you a little synopsis of how to find each one instead of you writing it all out, so that you have your foldables for your written notes, and here are some examples. Here's our first example. It's asking us to find the domain. So the domain comes from the denominator. So in this denominator here, let's take a look at the domain. The domain is going to be from negative infinity to negative 1, and then pick it up at 1 to positive infinity. We're going to go ahead and simplify that numerator to be x minus 1 and x plus 1, I should say factor, because it's dots, the difference of two squares, so this is gone now. And then I notice that this factor, x plus 1, and this denominator factor, x plus 1, can be simplified, reduced out, so that means that that point of discontinuity, which was at x equals negative 1, and I should put a negative there, is now a whole, because it's removable. So because it's removable, we need to go ahead and find the ordered pair. So when we substitute negative 1 into the numerator, which is all that's left, x minus 1, because that's what we're going to be graphing, is y equals x minus 1, or f of x equals x minus 1. When I plug negative 1 into this, I get negative 1 minus 1, negative 2. So there's my whole. And I kind of put in here, this little man was telling you also how to find that whole. So at negative 1, negative 2, I have a whole. And what that means is I'm going to go ahead and draw an open circle. And then I'm going to graph the equation that we're so used to, y equals mx plus b, with a slope of 1. So I start with my y-intercept, and then I go up 1 over 1. And then I can go backwards, down 1 over 1, which is my whole. So there is my linear line, and send it backwards, it'll just give me the rest of the line. And keep in mind that whole there has to be open, because it's not, the domain doesn't go through there, it's undefined at that point. Okay, so that's that example. Let's take a look at the next example. In this example here, it's asking for the horizontal asymptote. But once again, if you refer back to your foldable, notice the degrees. I have 2 over 2. Well, since 2 equals 2, that means they're equal. And because they're equal, according to the foldable, you look at the coefficients. Exponents are the same. Divide your coefficients. So my coefficient in the numerator is a 1. So because these are equal, I look at the coefficients of x squared and of the numerator and denominator. So there is my horizontal asymptote, or you can put it as a decimal. It doesn't matter to me. Next example. Okay, in example 3, they want us to identify each of the following. Let's start with the x-intercept. For the x-intercept, we're going to look at the numerator. The numerator is 3. So I'm going to set that equal to 0. And I cannot solve for x, so therefore there are no or none for x-intercepts. For the y-intercept, we let all the x's equal 0. So 3 over 0 squared minus 2 times 0 minus 8. When I simplify that, my y-intercept ends up being 3 negative 3 over 8, or 3 over negative 8, which is about negative 0.4. So for the y-intercept, it's going to be 0 always for x, and then negative 0.4. So that is 0, this value right there. Let's go ahead and take a look at the next thing. So we got the x and the y-intercepts. Let's take a look at the removable discontinuity. In order to do that, we factor the numerator and denominator, in this case just the denominator. Notice nothing cancels out with the numerator, so none. The vertical asymptote I get from the denominator that I just factored, so x equals 4, x equals -2, so I draw my asymptotes. And at 4, so those are my vertical asymptotes, don't cross those fences. The horizontal asymptote, I look at the k plus k, there is no plus k, so therefore, since there is no plus k, I go back to my foldable and I look at the degree of the numerator. The degree of the numerator is 0 since there is no x value, and that is smaller than the degree of the denominator, which is 2. So therefore, my horizontal asymptote is y equals 0, which ends up being my x-axis. The domain. To do the domain, we look at the asymptotes from left to right. So from left, all the negative values work until I get to -2. Then at that asymptote, I have a little break. And then from -2 to 4, any of those values work. But then I take a break. And then from 4 to positive infinity, all those numbers work. So there's my domain. For my range, I start from the bottom. I end up at negative infinities work all the way up to 0 because that's my asymptote, and then from 0 to infinity. So to graph it, I already have 1 point, and I know I can't cross the asymptote, so I just rough sketch. So that ends up being an upside down parabola. The other value I can choose is anywhere on the left of my asymptote or my right of the asymptote. I'm going to pick 5, and I'm going to substitute 5 in here. And when I substitute 5, I end up with 5 take away 4 times 5 plus 2, and that simplifies to 3/7. Yeah, 3/7. So then I'm going to plot the point 5, 3/7, but 3/7 is about 0.43. So 5 and 0.43, and then once again asymptotes help to rough sketch, and because these are symmetric, the other curve is on the other side. If you want to, you can always get another point below -2 to kind of see where it is. I'm okay with just these 2 points. That's enough data for me for as far as graphing. If you have any questions, ask in class. See you tomorrow.